Welcome to another video. Right here we have another problem to find all natural numbers such that 2 to the n plus n divides 8 to the n plus n. Clearly, we know if we didn't have the n's, 2 to the n divides 8 to the n. But once you have something added to it that is not consistent, well, that makes our options more difficult to find. So I clearly know that this is the cube of this. 8 to the n is the cube of 2 to the n. But that's all I know. So I better find another way of representing this so I can make some comparison and at least make some guesses. Let's get into the video. So this problem turned out to be not as complicated as I feared it was going to be because I immediately recognized what I said before. So let's do it here. We know that 8 to the n is equal to 2 cubed to the n, which you can switch the positions. It is 2 to the n cubed. So we could actually rewrite this problem and say that 2 to the n plus n divides, well, this is the symbol for divides 2 to the n cubed plus n. Now, if I start testing numbers, I may be fortunate to figure out what numbers would work. Okay? For example, let's try 1. Remember, we're dealing with natural numbers. Even from here, if I plug in 1, 2 to the 1 is 2 plus 1, that's 3. 8 to the 1 plus 1 is 9. 3 divides 9, so 1 is one of our answers. So it is either that's the only answer or, well, let's try another number. Let's try 2. If you plug in 2, 2 squared plus 2 will be 4 plus 2, that's 6. If you square this, it's 64. 64 plus 2 is 66. Oh, 2 works. So usually problems like this, it is either many numbers work, then you need a formula for it, or just a few numbers or just few numbers work, or nothing works. Okay, or everything works. So we've tested 2 numbers and they work. Let's try 3. 8 to the 3rd is going to be hard for me to do, but that's 2 to the 6th. No, 2 to the 9th. Ooh, that's a big number. So 2 to the 9th is 512. 512 plus 3 is going to be 515. And if I put 3 here, it's going to be 2 to the 3rd is 8. 8 plus 3 is 11. 11 does not divide 515, so 3 does not work. So I already know not every number is going to work. So let's go here and find a way to manipulate this. You see, something I've seen. Because of the presence of a cube here, I'm beginning to think of the difference of cubes or the sum of cubes, like changing this expression to some factoring that will contain this. Okay, so see what I'm going to say. 2 to the n cubed plus n can be written as 2 to the n cubed plus n cubed minus n cubed plus n. This was the manipulation that saved me, because at this point I didn't change anything. I have 2 to the n cubed plus n cubed minus n cubed plus n. Nothing has changed. So I'm going to take care of these two by themselves. So this simply means, let's come here. This will be sum of cubes minus n cubed plus n. That's how I'm going to treat it. Okay? So this is going to be So if I put these two together, it's going to have the vibes of x cubed plus n cubed, which is going to be x plus n times x squared plus xn plus n squared. That's how you factor the sum of cubes. So if I use that here, see what I'm going to get. I'm going to get 2 to the n plus n, boom, boom. Okay, multiplied by the square of this. So if I square this, it's going to be 4 to the n. It doesn't matter. Let me just write this as 2 to the n squared plus the product of these two is going to be n 2 to the n plus n squared. Okay, minus, so I'm done factoring this. I'm just going to write this minus n cubed plus n. Okay? Don't forget that this long thing I just wrote is basically the right-hand side. So what I'm going to do is say the only way that this would divide this. By the way, look, we have two terms in this expression. There is one term here. This whole thing is a single term. And this is, we can actually put this together, okay? It doesn't matter. We'll put this together later. But I want you to see clearly that 2 to the n plus n is here. So it means this will divide this, which means that this has to divide the second portion. That's a basic theorem. Watch this. If A divides B minus C, and A divides B, then A must divide C. So if you have two numbers, you add or subtract. For example, if you have, let's do it here, 6 plus or minus something, let's say k, and you want to divide it by 3. If we already know that 3 will divide this number, whatever number you generate, we don't know what k is, but if we know 3 will divide 6 plus a number, and clearly we know 3 divides 6, then that number we don't know, 3 must divide it. Otherwise, whatever we said was not true. Okay? So, if 3 divides 6 plus or minus something, and we know 3 divides this, then 3 must divide this number also. So this number has got to be 0 or any multiple of 3. So that's the secret to it. That's the same thing. If we claim that this divides this expression, this number is what I just rewrote here, and we know that this divides this, then it must also divide this. Okay, let's clean that up. That's all, and that's the secret to solving this. 2 to the n plus n divides 2 to the n plus n times, I'm going to write this as 4 to the n just to make my life easy. 4 to the n plus n 2 to the n plus n 2 to the n plus n squared minus, I'm going to open parentheses and write this as, you know what? I might just factor out n minus n times n squared minus 1. Okay? So, if 2 to the n plus n divides the right-hand side, then 2 to the n plus n must divide n times n squared minus 1. So my problem has gone away from me trying to figure out two exponential functions to comparing an exponential function to a polynomial, which makes your life a lot easier, because now I'm no longer dealing with this exponential part, because I can see this divides this. This must also divide this, because this is supposed to divide everything according to the question we have here. Okay, so now what does this mean? This means that is 2 to the n plus n must be less than or equal to this guy. Must be less than or equal to, you know what? I'm going to go back and rewrite it in the original form, which is n cubed minus n. Yeah, because I need that. N cubed minus n. Let me rewrite this, go back to n cubed minus n. So now this is easier for me to deal with. How do I know it is easier to deal with? I can make some claims now. Watch this. 2 to the n plus n is less than or equal to n cubed minus n. If I remove this n, I know that 2 to the n is less than or equal to n cubed minus n. Okay, I'm saying this side is less than the right-hand side. Well, if I reduce this side by removing the n, I am not changing the fact. In fact, I'm making the left-hand side smaller. It is still less than the right-hand side. I can make the right-hand side even bigger, right? My claim will still be correct. So I'm saying 2 to the n is less than or equal to n cubed. But this is not always true. Okay? If n is greater than or equal to 10, this statement will not be true. 2 raised to power 10 is 1024, but 10 raised to power 3 is 1000. So once you get to the number 10, this relationship can no longer hold. So we have set an upper bound or an upper limit for the number of numbers we can try. Okay, so that's what makes this beautiful, because you don't have to test every number. You can just start from 1 to 10. So if n is greater than or equal to 10, 2 to the n greater than or equal to n cubed does not hold. Therefore, n must be less than or equal to 9. So all the numbers you want to try must be from 1 to 9. And remember, from the start, we already tried 1 and 2, and we knew 3 did not work. 1 and 2 worked, yes, but 3 didn't work. So, but we still have to show it. Okay? So now all we have to show is that 2 to the n plus n divides n cubed minus n. In fact, now I can say, therefore, we test 2 to the n plus n divides. If I factor this, it's going to be n times n cubed, n squared minus 1, which is the same thing as n times n minus 1 times n plus 1. That is the complete factored form. Okay? So let's test the numbers. Numbers, we do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And let's make a table. Here we're going to have 2 to the n plus n. Let's write it. Chop. And here we're going to have n times n minus 1 times n plus 1. Okay, so this makes our answers easy, or easy to see. Instead of us doing n cubed minus n, the factored form is easier. Watch this. So when n is 1, this is going to be 3. And when n is 1, this is going to be 0. 3 divides 0. Check. Any 0 is divisible by any number, so 1 works. We go to 2. 2 to the 2 plus n is going to be 2 squared plus 2 is going to be 6. And I know at the beginning this is going to be 2 times 1 times 3. That's 6. Oh, the numbers I'm even getting are smaller numbers. Okay, 6 divides 6. Let's try 3 now. 2 cubed plus 3 is 8 plus 3, that's 11. Here it's going to be 3 times 2 times 4. 3 times 2 times 4 is going to be, my math is not 24. Okay. Now, this is a yes, this is a no. Let's try 4. 2 to the 4th plus 4 is going to be 16 plus 4, that's 20. Okay? Here we're going to have 4 times 3 times 5. That's going to be 12 times 5, 60. Oh, it works. Now we go to the next one, 5. 2 to the 5th plus 5 is going to be 32 plus 5, that's 37. 37. Okay? And this is going to be 5 times 4 times 6. 5 times 4 is 20. 20 times 6 is 120. Okay? Clearly, this does not work. So we're going to try 6. 2 to the 6 plus 6 is going to be 64 plus 6. That's 70. And this is going to be, using 6 times 5 times 7. 6 times 5 times 7 is going to be, take the 2, put it in the 5, that gives you 10. So that's 3 times 10 times 7. So that's 3 times 10 times 7 is going to be, hey, 210. Check. That works. Okay, I'm going to leave the rest of the math for you to do because there are no other answers. N belongs in this set of 1, 2, 4, and 6. 4 and 6. Any of these numbers is going to work. No other number works. Leave a comment in the comment section. This was a beautiful one. Never stop learning. Those who stop learning, stop living. Bye-bye.